because this thing we'll see one by one in this courses. So first we are discussing about the mode of the heat transfer. How many heat transfer mode is available and whether it is natural or so. First mode of heat transfer is the conduction. There is a basic mode of heat transfer, conduction heat transfer. Second mode of heat transfer is the convection. And third mode of heat transfer is the radiation. There are three types of heat transfer is taking place: conduction, convection, radiation. Out of these three, the conduction and radiation both are natural heat transfer. Both are the natural. By nature it is happening. Conduction and in that case. On the other cases, the convection, in the convection, two ways it can be done. One is artificially. One we can do by artificially, by the fan, blower, pumps, etc. That is artificial. We have to run the fan, blower, pumps by some motors. But electrical energy is converted into the mechanical energy. And there is also another kind of the convection is there. There is the free convection or natural convection. Free convection or natural convection. That is by nature it is happening. How it is happening? Buoyancy driven flow. Because convection is due to only the bulk fluid motion. Convection always happening due to the bulk fluid motion. So this bulk motion of the fluid shall be created by artificially, by fan, blower or pumps, or can be natural. Naturally, how it will comes? By the temperature difference. Because there is a temperature difference cause the density difference. And density difference cause the buoyancy force. Because of the buoyancy, the flow will be taking place. So this kind of the flow is known as the buoyancy driven flow. So free convection is due to the buoyancy driven flow. So these three are the basic mode of heat transfer. First one is the conduction heat transfer. It is by natural, it is happening. How it is happening will come recently. We'll see it. Next is the convection. Next is the radiation. Example, if I give you, it will be better to understand. The conduction, how it is. Conduction can be happen over the, basically for the case of the solid, mostly conduction is happening. Because solid are the good conductor of heat. Some kind of the solid is there. So solid, how many types of the solid is there? Solids, it may be metallic, it may be non-metallic. Metallic, those solids which are metallic, their conduction is happening due to the free electrons. Or valence electrons. So which are the metal? Just like metal, we are talking about the copper. We can tell the aluminium, steel. Then we can say about the silver, etc. All other metals. This kind of the metallic solid having the free or valence electron, which are very much useful to conduct the heat as well as electricity. And 70% of heat transfer is for the solid, it is happening due to the metallic. 70%, nearly 70% heat transfer is occurring. Conduction is occurring due to the metal, or metals. And remaining 30% is due to for the non-metallic. In case of the non-metallic, what is the reason for the non-metallic cases conduction, why it is happening? Because of the non-metallic cases, the things lattice vibrational waves. That is the physics behind it. Lattice vibrational wave. What is the lattice? Lattice is nothing but an array of the molecules. Like if you consider the diamond, just non-metallic, one good conductor is the diamond, is a very good conductor. So here what is there? Number of molecules are in a array form. They are forming one array. So diamond is a form of carbon. There are number of molecules are there. All molecules are in form of a array in this. Similar way, there is another lattice is there. So all lattice is causing one vibration. One lattice to other lattice, the vibration energy is transferred in form of a wave. That is the actually cause for the heat conduction. So one molecule is getting heated, vibration started in the lattice, and this heat energy is flows from one lattice to other lattice in form of the lattice vibrational wave. This is case for the non-metallic cases. So solid, there is a two chances is there, metallic or non-metallic. So we have given one example for the diamond, which is a very good conductor. Similarly, one non-metallic glass is also there, which is not a good conductor because it is amorphous. There is a void in between two molecules. There is a void in between two molecules. As there is a void, so no conduction is taking place. Very less amount of conduction is taking place in the case of the glasses. So one example, diamond, which is a very good conductor. Another example is a bad conductor, that is a glass. So first mode of heat transfer, mainly conduction is happening for the solids. So solids, we have seen how many kinds of the solids are there, metallic and non-metallic. Maximum 70% is for the metallic cases and remaining 30% for non-metallic. But for the non-metallic, diamond is a good conductor, quartz is a good conductor. They're all, graphite is a very good conductor. They're all very good conductor due to cause of the lattice formation. And because of this lattice vibrational wave propagation is causing for the heat conduction. Then the question comes whether the conduction happens in the liquid and gases. Yes, of course. For the liquid and gases also there is a conduction happens, but lesser than the solid, comparatively lesser than the solid. But what is the cause for it? We'll discuss about this thing. What is the cause for the liquid and gases conduction, heat conduction in liquids and gases? The main cause for the conduction in the liquid and gases, that is the molecular momentum transfer. This term I think you have heard of in your viscosity topic also, molecular momentum transfer. So one molecule is getting excited and it is transferred its momentum to the other molecule during the collision, during the elastic collision. Let you take, in the case of the gas, in a gas chamber, if you consider in the kinetic theory of the gases, in the gas chamber, there are enormous number of molecules are there. Now in this side, I am applying the heat. In this side, I am applying the heat. So very high temperature I am keeping or maintaining here. And in that side there is ambient temperature. What will be happen? Which molecules will comes here? It will get excited due to the high amount of the energy. So this velocity or RMS velocity of this molecule will increase. I am talking about only for gases, ideal gases. That's why kinetic theory I am talking about here. So RMS velocity will be increased due to cause of the temperature. As the RMS velocity will be increased, it will goes for the high kinetic energy. And then one high kinetic energy molecules, if collides with the low kinetic energy molecule, it will transfer the kinetic energy from one molecule to other molecule in form of the heat. That is known as the molecular momentum transfer. This molecular momentum transfer is the cause for the heat conduction. Heat conduction. Similarly, the case for the liquid also. Liquid, not for the kinetic energy of kinetic energy theory is not applicable for the liquid, but there also the similar case of happening. So the molecules having a lot of energies, vibration energy, rotation energy, translation energy, everything. So one molecules when collides with the other molecules, it transferred its energy in form of the heat. That is nothing but the heat conduction. That is the cause for the heat conduction, molecular momentum transfer. So in that case, in the case of the gases or liquids, heat conduction, cause for the heat conduction for gases or liquid is the molecular momentum transfer. If you increase the temperature, velocity will be increased, randomness will be increased, collision will be increased, molecular momentum transfer will be increased. So the heat conduction will also increase in case of the liquid and gases. Heat conduction will also increase for the case of the liquid and gases. That is the basic idea I'm giving. What is the physics behind the in here. I'll come slightly details what is the value of the what is the thermal conductivity value, but you don't know till now what is thermal conductivity will come into the picture slowly. So this idea I'm giving you why heat conduction is taking place for the case of the solid, liquid, and gases. What are the reasons behind it? So heat conduction. So simply we are concluding this thing. Heat conduction can be take place for the case of the solid, for the case of the liquid, for the case of the gases. In the solid, there is a two kind of solid, metallic, non-metallic. Metallic, two-part, crystalline, amorphous. What are the causes behind it? Metallic is the free electrons. Free electrons is cause for the conduction. Crystalline, lattice, vibrational wave propagation. Amorphous also lattice vibrational wave propagation, but there is a void between two molecules, so it is a less. So for non-metallic, it's due to the lattice vibrational wave propagation. So for the crystalline, it is advantageous because it is a well, the array is a well setup. For the liquid and gases, molecular momentum transfer. That's the cause for the heat conduction. What is the cause for the heat convection? Heat convection causes the bulk fluid motion. That already I have discussed. I just make it heat convection. Heat convection, two ways we can do it. One is the main reason is the bulk motion of fluid. That is the one and only reason. You have to create the motion in the fluid. If the fluid is stagnant, there is no convection. There is only conduction. Or radiation may be happening. But if the fluid is in motion, then only convection will comes into the picture. Convection mode of the heat transfer will comes into the picture. So it can be artificially done or it can be done naturally. It can be occurs naturally also. So free or natural convection or forced or artificial convection. Two kinds of convections. Forcefully we are doing by outside. We are giving some fan using. We can use the blowers. We can use the pumps for the liquid, incompressible fluid. The free convection is the buoyancy driven flow. Buoyancy driven flow. Why buoyancy is created? Because of the temperature difference. So delta T, temperature difference, is causing for the density difference. And density difference is causing for the buoyancy force. So that is the cases occurring in case of the convection. That is happening in the convection. In details, we'll talk about in the later when we are taking the convection. One by one, slowly we'll do it. Next one is the heat radiation or radiative heat transfer. Heat radiation. Heat radiation, for that purpose, no medium is required, literally. There is no requirement of the medium. Heat conduction, there is required solid, liquid, all the cases. Heat convection, there is a fluid medium is required, but heat radiation, literally it can be occurs in the vacuum also. So no medium is required. So as there is no medium is required, then what is the reason for this? How it is happening? The reason is the electromagnetic wave propagation. The example, from the sun, how heat is coming into the earth. The mode of the heat transfer is the radiation. Because this heat is coming entirely from the vacuum. Through the vacuum. Medium, there is no medium. Vacuum. So heat radiation, there is no requirement of the medium. So it is in form of the electromagnetic wave propagation it is happening. Heat radiation. So all mode of heat transfer is very significant. But first we will discuss about the heat conduction. In details, heat conduction will start with giving some